Hello, welcome to GP Podcast. We are standing on the very edge of a new robotic age. It's an era where the line between a machine and a living organism is blurring in ways that, honestly, feel like they're pulled straight from science fiction. But this isn't a movie, this is happening right now.
That single sentence, it describes a new generation of humanoids that are starting to emerge, and they're challenging everything we thought we knew about what a robot could be. And believe me, this is just the beginning.
So what are we actually looking at here? Well, down in Shenzhen, researchers have unveiled a soft humanoid called GrowHR, and it represents just a radical departure from traditional robotics. It looks less to mechanics and much more to the blueprint of biology for its design.
Most humanoids, you see, are built on these rigid, column-like skeletons. They're strong, for sure, but they're not very adaptable. GrowHR is completely different. It's built on what its creators call bone-inspired growable linkages. Think about our own bones. They're not just stiff rods, right? They grow, they absorb impact, they're strong but also lightweight. This robot tries to mimic that biological logic, and that gives it this incredible ability to adapt its own shape on the fly.
And the results of copying biology? They're just staggering. These bone-like structures can extend up to 315% of their original length. Just imagine an arm that can suddenly become 3 times longer to grab something off a high shelf. That's the kind of adaptability we're talking about. This growth isn't just in its limbs either. The entire robot can increase its height by 278%. It goes from this compact little form to nearly 1.4 meters tall, so it can shrink down to get through tight spaces and then just expand to its full height whenever it needs to. A level of physical transformation that a traditional robot just can't touch.
But here's the thing, this isn't just a party trick for changing size. This bio-inspired growth acts as a massive performance amplifier. When its growable limbs work together with its joint motors, its crawling speed increases by over 1,000 times compared to just using the motors alone. The growth and the movement are one single, powerful, and deeply integrated system.
And this versatility is really what makes the design so revolutionary. The entire robot weighs only 4.5 kilograms, that's about 10 pounds, which makes it light enough to float, swim, and even walk on the surface of water. And get this, with some simple attachments like ducted fans, it's capable of short-range flight. The exact same body can operate on land, in water, and in the air. So a single shape-shifting robot is incredible, right? But what happens when you take this tech to the next level? The real leap forward is deploying entire teams of humanoids that can work together as a single, coordinated unit. I want you to picture this. This is a demo from another Shenzhen company, Limx Dynamics. They've packed 18 of their robots into standard shipping containers to simulate a real-world deployment. The doors swing open, and with zero human intervention, they stand up, walk out, and start moving together in perfect formation. So how do they do that? The magic behind it is a technology called KOSA, or Cognitive OS of Agents. The easiest way to think about it is like a shared brain, or a hive mind, for the entire fleet. It lets the group make decisions and plan movements together almost instantly. This whole sequence is a major step forward for practical robotics. They emerge, they calibrate themselves, they form up, and then they execute a task together. This isn't just some stunt in a lab. This is a real demonstration of how a robotic workforce could be deployed in an industrial setting. But this revolution isn't just about labor and logistics. These advanced humanoids are now starting to enter fields that we once thought were uniquely human, everything from the creative arts to the most extreme environments you can imagine. It's a question philosophers have debated for a long time, but now we're seeing it play out in the real world. I want you to meet IDEA, a humanoid robot that isn't just creating art, but is actually designing architecture. Yeah, you heard that right. Ada has designed a complete concept for a retro-futuristic pod house, one that's meant for humans and robots to live in together. Using its robotic arm, it makes everything from pen sketches to painted artworks, and its work has been shown in some of the most prestigious art venues on the planet. This is AI as a genuine creative partner, and it's pushing the boundaries of what we even consider art. And if an artist robot isn't surprising enough for you, let's pivot to the most extreme environment of all, space. The next generation of astronauts, well, they might not be human at all. Companies like Engine AI are developing humanoids like the PM-01 specifically to be robotic astronauts. They'd be capable of handling super risky tasks like station repairs out in the vacuum of space. And at the same time, others are solving the communication problem. The Teen Kong robot recently connected directly to a low Earth orbit satellite, proving these machines can be controlled from anywhere, no matter how remote.
Okay, so we have shapeshifters, coordinated teams, artists, astronauts. But what's the economic engine that's making all of this even possible? Well, the answer lies in a manufacturing ecosystem that is scaling at an unbelievable pace.
The sheer scale of this market is just astounding. Of all the humanoid robots installed globally in 2025, a staggering 80% are in China. This isn't some future prediction, this is the reality right now. This concentration creates this powerful feedback loop, accelerating everything from data collection and software development to cost reduction on a national scale.
And behind that number is a massive industrial ecosystem. You've got factories dedicated to just producing robot joints, which are half the cost of a humanoid, opening up with the capacity to make over 100,000 units a year. There are nearly 500,000 intelligent robotics companies in the country. This complete supply chain is what's driving costs down and enabling this rapid explosion of innovation.
All of this activity is setting the stage for a new kind of global competition. A race to define the future of labor, creativity, and even exploration through humanoid robotics.
And this massive scale, well, it isn't going unnoticed. Leaders in the field, like Elon Musk, are now publicly pointing to China as their biggest competitor in the humanoid space. They recognize that the country's strength isn't just in building the robots, but in its proven ability to scale manufacturing and AI at an absolutely incredible speed.
And this brings us to the big question, the one I want to leave you with. As this technology accelerates and the industrial competition heats up, the entire landscape of global technology and labor is set to shift dramatically. If you liked the video, subscribe, leave a like, comment on what you liked most, and share the video. Catch you in the next one.